Hello all and welcome to the first video lecture of AP Calculus 2. This is also sometimes referred to as BC Calculus. The AP calls it AB for Calculus 1 and BC for Calculus 2 because there's the overlap. And that's sort of what we're going to be doing for the first couple months. Is what I like to do to start off Calculus 2 is do some reteaching at a very accelerated pace of Calculus 1. So you'll notice here we're starting with Chapter 2, Section 3, and usually we finish that up around Thanksgiving. And it just gives us a chance to, one, review everything. I give you some tips on how the AP might ask different questions about these same topics, but you'll definitely see plenty of Calculus 1 topics if you end up taking the AP test. And so it's just nice to review, especially with how challenging and different the end of last year was. So we're going to be starting with Chapter 2. You'll want to take notes with the videos and or use it in some combination with the paper filled out notes that are available on, as PDFs on Google Classroom. How you use those different resources is up to you. I'll be gathering data through AP Classroom and things like that to just see how well you're mastering that material. So however you are seeing fit, that's great. The things that will be consistent, however you're taking notes, make sure you're getting the content. And then I'll be collecting homework, so you'll see the chapter and section here. You'll have recommended homework problems. As a reminder, I'm not expecting every single person to finish every single assignment. If you're working for, on average, 30 minutes a day, and when I say that, I do mean it, because some of these days you're going to be working maybe only 15 minutes and you'll do the whole assignment. That means that maybe another day during the course, you're going to be working for 45 minutes. I'll try to keep the weeks averaged out, but I just want to give you that heads up. That's a big thing with the honors level class, is that some of these days are just going to go over that 35 minutes, especially since I will expect you to be checking your answers in the back of the book and doing corrections so that you know whether you've mastered a topic or not. When you've checked your answers in the book, you'll have basically 3 different possible outcomes. You'll have, oh, I'm crushing it. I got 1 wrong, but that's because I did some weird things with negatives. I fixed it. I'm great. I'm going to post the presentation. The next one would be, oh, okay, I got a few wrong. Fixed most of them. Feel pretty confident. I'm going to post the presentation. But there was like 1 or 2 that I was really stuck on. So let's say you were stuck on 19 and 23 in this range. You can go to Google Classroom, this assignment where you got this video, where you got these notes, and there's an option called Homework Nomination Forms. Open that form up and just click on the ones you got stuck on. So you can click on one problem or you can click on all of them. I can't promise a response to every single one, but definitely if multiple students are asking about the same question, I'll post something that's a written explanation or maybe even a video of explanation if like everyone's stuck on it. So make sure you do that. If you're super stuck, please make sure that you're making a one-on-one appointment with me before you are finishing and posting the presentation. So that means making that one-on-one appointment on Friday morning, maybe for this one, or just at some point so that you know that you can ask questions about it. Because clearly if you got every single problem wrong or all but 1 wrong, that means that you might need to ask additional questions. So those are your possible outcomes when you check the answer. So we're going to look at these just as a reminder of limits. Hopefully this, again, feels very much like review. I'm going to go through it pretty quickly, but please feel free to pause the video if you get stuck. Ask me any questions in the comments on Google Classroom, or if you have our one-on-one meeting, you haven't had that yet, you can ask me questions. Ask me questions then. So we're going to start today talking about evaluating definite limits. So as a reminder, limits is the value which a function approaches from 1 or more directions. And a definite limit means that the value that it's approaching is a number. So we'll talk about as x approaches infinity and negative infinity in a little bit. Today's work is just about things like what we see here, where x is approaching in this case, pi over 3. That's a definite limit. Pi over 3 is a number. Now, in most cases, the limit is just equal to what would happen when you plugged it in. So what I'm going to do is often put just additional notes here so that we still have space to work through the problems here. So what I see some of my more advanced students, like those of you, will do is that you'll forget that this is true, is that most of the time you can just plug in that number. And I see students who will jump immediately to these complicated methods, and it's just like, nope, just plug in whatever that definite value is. And that's what's going to happen here. So sine of x, the limit as x approaches pi over 3 is just sine of pi over 3. If you don't remember what that is, it's helpful to make sure that you're still remembering how to do some of your trig values by hand, whether it's in your head, whether it's using the unit circle, whatever method makes sense for you. I'm going to remind you the unit circle. Pi over 3 is the same as 60. It's here. And sine is the y. And so you've got your largest sine value. Remember, all unit circle values are 0, 1/2, root 2 over 2, root 3 over 2, root 3 over 2, or 1. And since you see here, our y-axis, we're pretty high, but we're not all the way at the top, the maximum of the circle. We're going to be looking at our second highest number, and it's positive. So that's root 3 over 2. Now, of course, because it's math, even though this is how it works for 99.9% of numbers and functions, we're obviously going to be spending some time looking at the ones that don't work out as nicely. So in this case, limit as x approaches 1 of x squared minus 1 over x minus 1. If you plug in that value, you end up with a 0 in the denominator. So you end up with what's called a discontinuity, which means that you can't actually, there isn't a point there, like there isn't an f of a. So what you can ask yourself is, does it simplify? So in this case, some of you are going to be like, I'm going to use L'Hopital's, I'm going to be tricky, I'm going to do all these things. Please do practice some of your more basic ones. L'Hopital's is fine. If you don't remember what that is, that's okay. We're going to get to that as we get farther. But sometimes you don't need the most advanced tool ever to fix some of these early problems. X squared minus 1 is x plus 1, x minus 1 over x minus 1. Cancel, cancel. And now you can plug it in, meaning that this is x plus 1, where we're just taking our definite value, plugging it in, and we end up with 2. So it's a discontinuity, but it was a removable one. We just had to do a little factoring. One other important thing that we want to remember when we're reviewing limits is that a limit exists, and the way we say this is if and only if, and then has these two limits. Limit as x approaches n with a little negative looking thing or with a positive. And as I hope you would remember, these are your left hand and right hand limits. And a limit only exists if they're equal. So what that means is that we can't have a function from the left coming up here and then a function from the right. Both of these limits exist, but they're not equal to each other. This would be the left-hand limit because we're coming from the left-hand side approaching the point. And then here would be the right because we're coming from the right. So a limit only exists if it's something where these two are the same. It might have a discontinuity at this point, but then they're the same. So in this case, prove that the limit as x approaches 0 of the absolute value of x over x does not exist. When you see questions like this, what they're really asking you to do is show that the left hand and right hand limit aren't the same. So we're going to take those separately. When we're talking about absolute value, the left hand limits, as we're coming from the left side, we're coming from the x's being negative numbers, means that we have a positive is always in the numerator, and then the x is negative when we're on the left-hand side. So what we end up with then is that the limit as x approaches 0 from the left, these two values are the same, but this one's always negative, so this would be -1. Alternatively, the right-hand limit will always end up with a positive number for both the numerator and denominator. So since it's always going to be positive, we just can write it as x over x, and so then the right-hand limit is +1. And since we know -1 doesn't equal +1, then the limit itself does not exist. Whoop, that's jumping ahead a little bit. Let me know if you have any questions in the comments below or in our one-on-one meeting if we haven't had that already, or you can just shoot me an email or a private comment, whichever you prefer. If you're stuck on anything, please review maybe some of the course materials, and I'll be available all throughout the week, especially tomorrow on Wednesday, if you have any particulars that you'd like to address. Talk to you later.